OK，我们先 go through 那个上个星期的 exercise，and then after that, don't only then I continue with the lesson. OK, so today I'm not going to teach much. OK，我们今天会讲到一点点force, still in force, and then after that we'll go into more further. OK, in the next class. So this one we take this as a Q&A, short Q&A session. Any question for the previous exercise? Okay, any question for the previous exercise? Please let me know in the chat. Okay, let me know if you don't feel like talking, then just type in chat. Yeah, by the way, 之前那个是 2.5 2.5 and 2. What is that? 2.3 and 2.5. Understanding the effects of a force. Let me bring this up. Let me bring this up. One, 这一张. Okay, so I know some of you have finished, and I know some of you haven't finished, and it's okay. I'm not going to check your homework anyway, because you are now, of course, you are now in Form 4, you are grown-ups, and I don't have to check the homework and stuff. So you know your stuff, and just that any questions, you just let me know, all right? So all the handouts, all the exercise given is the exercise that I got from different sources, and also different physics books. So usually you see 有一些练习是 like the ABC got 1 to 70. It's very many questions. So 1 to 70 is actually I got from all the physics books, right? I took out like from one book, from another book, and then I put it together all together. So if you do the worksheet, meaning that you are doing different physics books. So if you can finish all of them and you check your answer and you do every handout given, then it should be no problem with you scoring physics, right? It should be no problem with you scoring physics, because you already you are meaning that you do the worksheet, you are doing different types of questions, different types of scenarios, so you get more familiar with how the question is asked. Okay, you get more familiar. Of course, I will give more exercise in the future. Okay, these are just the revision exercise. You see all this ABC, right? So every time after I finish one lesson, I usually give this type of exercise ABC, and then you will see structural question comes later. Okay, structural question, of course, is more we call the hot question. It's like high thinking skill one. All right. So of course that one I will give you as well, but this is just for revision. So my point is that you can do the handout, or also you can choose to not do it. But of course, at the end of the day, you know that it's for your own good, right? It's for your own good, right? So in physics, there's no secret in scoring physics. It's just practice as many as you can, as much as you can, and just to understand the concept behind it, right? So if you have question, please ask. Don't feel shy, or don't feel afraid to ask or anything like that lah. Just ask lah. Okay, nothing to worry about. Everybody makes mistakes, right? Everybody makes mistakes. Okay, now if you have question for this exercise, please type in the chat which question you want to discuss. If you have no question, it's okay. I'm going to pick a few, and then I'm going to talk a little bit about it. Then we move on, right? Then we move on. Now let's see this one. Let's see. Okay, number 3. If you lost the worksheet or you don't have the worksheet, you find it in a WhatsApp group, okay, or you can just look at the screen here. Now, number 3, let me zoom in a little bit. Okay, okay, everybody look at number 3. Diagram 9 shows 2 trolleys X and Y being pushed with equal constant forces at the same time. Okay, the mass of trolley X is 2m and the mass of trolley Y is m. Which of the following is the same for both X and Y? Now, A, increase in momentum in 1 second. Increase in momentum in 1 second. You notice the sentence here. Increase in momentum meaning that is the change in momentum. Okay, change in momentum in 1 second. What is change in momentum in 1 second? Meaning that delta. Okay, I use this triangle. This triangle symbol means delta. It means that change. Okay, you are right. Delta P means the change in momentum divided by time. This is what the sentence means. The increase in momentum in 1 second. Okay, so what formula is change of momentum divided by time? Okay, you have your impulse formula. Ft equals to mv minus mu. Right? This is the impulse Ft. If you bring this t over there, so F equals to mv minus mu divided by t. So notice that on the other side here, this one, mv minus mu divided by t. This one is we call it rate of change of momentum. Okay? Because on top you have change of momentum, and if it is divided by time, meaning that it is how fast the change of momentum happens. So in this case, we call it rate of change of momentum. Okay? So 3a, meaning that it is saying the rate of change of momentum. They are the same. Okay? Which is, yes, it is correct. Okay? Because if you see for x, the mass is different, right? But of course, if I apply the same force, both the trolley will be moving at different velocity. Of course, the higher mass, it will move slower. Okay, on top, this one moves slower. The trolley with a lower mass will move higher, faster. Okay, but here we are only interested in the increase in momentum. Doesn't matter the speed faster or slower. You have the first one, you have slow speed but high mass, the momentum. The second one, you have low mass but high speed. But at the end, they are still having the same momentum. Okay, which is why your answer is A. Okay, so look at B. B said the increase in velocity in 1 second. Of course, this is wrong. Why? Because increase in velocity in 1 second means acceleration. Okay, so this sentence means saying that acceleration is different. No, sorry. It's saying that the acceleration is same. But in fact, the acceleration of that two trolley is different because they are having different mass. Okay, you learn about F equals to ma. So if they have different mass, then the acceleration is different. Okay, so C is also wrong. Okay, so the correct answer would be 3A. Okay, I'll erase this one. And also look at number 4. Number 4, okay. For which of the following graph shows the relationship between mass and acceleration when the force applied is constant? Okay, how do you find the relation between force and mass? Acceleration. Okay, you see from the formula, m F equals to ma. Now, question says relationship between mass and acceleration when the force is constant. So imagine this force here is constant. A constant value means fixed, not change. Okay, so if you put the A over there, so F over A equals to M. Okay, so how do we look at this one? F over A, we say that M is directly proportional to F over A. Okay, M is directly proportional to F over A. So this one you can actually break down into two. First, we can write M is directly proportional to F. And second one, we can write M is inversely proportional to A, but directly proportional to 1 over A. Okay, so you look at the second one. We are also only interested in the second one here. Okay, second one here says that M is directly proportional to 1 over A. Okay, so if you were to plot your graph like M and 1 over A, you will get a straight line. And if you were to plot M and A, then you will get a curved line down. Okay, so this is inversely. Okay, so look from 4 here, which answer is the correct one? Okay, A, of course, out. Okay, because A with M down, out. Okay, B also out. And then you have C and D. Okay, of course, answer is D, because D, the graph shows that A is inversely proportional to M, which is the same as my graph down here. Okay, it's the same, 1 over M versus A, or A versus 1 over M. It's the same thing. Okay, so meaning that the answer for this one is D. Number 4 is D. Okay, of course you have the answer sheet already, just giving you extra explanation here. Okay, now what else? What else? Let's look at number 9. Okay, let's look at number 9. And a truck of mass 5,000 kg is moving with an acceleration of 1.5. If the total frictional force on the truck is 4500, what is the force exerted by the truck engine? Okay, use F net equals to MA. Now F net is F applied. Okay, in this case, it is the force applied by the truck's engine. So we use F thrust. Okay, thrust is the force applied by engine. F thrust, and then minus F friction, 等于 MA. Okay, because net force, you have to take a bigger force minus the lowest force, the lower force. So in this case, thrust is of course bigger. Friction is of course lower. Why? Because if the friction is higher than the thrust, then the truck will not be moving. So thrust has to be higher, right? So if thrust is higher, then we take thrust minus friction. Then there is a net there, right? Okay, so F thrust, we don't know F thrust, minus F friction is 4500 equals to, and the mass 5,000 times acceleration 1.5, right? So from here you do the algebra, you bring this and you panai. So F thrust is equals to 12000 Newton. Answer is B. let's look at another one. Question 10. A worker pulls. Okay, question 10. A worker. Let's do two more. Then we are done. We move on to the lesson. Okay. Now, number 10. A worker pulls a trolley of mass 50 kg with a force of 200 Newton. The frictional force between the trolley and the floor is 20. Okay. So in this case, we know that there is a net force acting to the right. Why? Because the cart is moving to the right, so there must be a net force acting to the right. So F equals to ma, F being the net. Okay, so how do we find the net force? You know that the worker is applying 200 N to the right, and there is an opposing force acting in another direction of 20. So the net would be, you take 200 minus 20, that is the net, which is 180 acting to the right. Okay, 200 minus 20 equals to the mass, 50 kg, times the acceleration. Okay, so acceleration you don't know, just put A. So 180 equals to 50A, then you can easily find your acceleration. Okay, 3.6. 3.6 m s minus square B. Okay, let's do a last one. Okay, diagram 8, number 12. Look at number 12. Diagram 8 shows a trolley of mass 3 kg placed on a rough ground and being pulled by a force of 5 N. Okay, so you see rough ground means there is frictional force. The trolley moves at constant velocity. Now, constant velocity, you have to ask yourself, if the trolley is moving at constant velocity, meaning that it is not accelerating. Okay, so A is equals to 0. If A is equals to 0, meaning that what? No net force. Okay, no net force, because if you put the formula MA, you put A is 0, then you get F net is also equals to 0. So meaning that there is no net force here. So no net force meaning that force are balanced. Okay, force are balanced. So the question asks, what is the frictional force between the trolley and the ground? So you know there's one force pulling it to the left, and since the force in the system is balanced, so we know that the friction acting here, the opposite direction, is the same as the force pulling it, 5.0 Newton. Okay, and this one only will give a balanced system. Okay, so frictional force is same as the force applied, which is 5 Newton. Remember this one. This one, the question always asks. Okay, always test your understanding on this one. Although sometimes it looks easy, but sometimes we will forget. Okay, let's move on to the lesson. Now, I'm going to teach a little bit about impulsive and impulse. Okay, now impulse and impulsive force. Okay, let's imagine. Let's take a scenario. Let's take a scenario. Let's imagine you are in a baseball game. Okay, you are in a. I have never played a baseball. I don't know if you did. I think baseball. This game is not as popular in Malaysia as in the Western countries. Okay, so let's say imagine you are in a baseball game. Okay, so in front of you, you see this very fast moving baseball. Okay, moving towards you. Now you have the baseball bat in your hand, and what happened? You lock your eyeball onto the baseball, and then you made a huge, nice swing. Okay, you made a huge, nice swing of the bat, and then you hit the ball, and then you're sending it up and far away in the air. Just take this scenario. Now, what happened here is that as you hit the baseball, it changes direction. Okay, so we can say that there is a momentum change of the baseball. The momentum of the baseball has changed. Why? First is because of the velocity of the baseball has changed. Okay, let me draw it out. Let me draw it out. A simple diagram. So this is the baseball bat. This is the baseball. Initially coming to you, and then after you hit, moves away, V. Okay, now the momentum of the ball has changed here. Why? Because the velocity, first is the velocity has changed. Initially, it is moving towards you, V, you, and then after maybe you hit it hard enough, okay, hard enough, and then sending it in increased speed. So you increase the speed of it, making the final speed greater. So the speed change here, and also second, the direction change, right? So momentum, we know that momentum is measure of mass and velocity. As long as there is a change between these two variables, then there is a change in momentum. So in this case, it's a speed change. Okay, so we know that there is this change of momentum, and if we want to write down this change of momentum, represent in mv minus mu, final momentum minus initial momentum. Okay, change. Now notice that to change the momentum of the baseball, you need to apply a force acting for a period of time. Also, we talked about this in the previous lecture, just like you stopping a car, right? To stop a car, you need to apply a force for a certain duration. So in that case, is you need to step the brake pedal. You step the brake pedal for a certain duration of time, and then you completely bring the car to a stop, meaning that you change the momentum of the car. It's the same case at this one. If you want to change the momentum of the baseball, you need to apply a force for a certain period of time. So I write down here force times time. Okay, now notice that in this formula, the time represents the time of impact. Okay, time of impact. So to hit the ball, to transfer the force to the baseball, you need contact, meaning that time of impact is the time between the contact between the, sorry, let me rephrase. Impact is the contact between the baseball and the baseball bat. Okay, so the time of impact is the time taken in that process. So in order to transfer the force, you need both the surface of the baseball bat and the baseball to be in contact, right? In order to transfer the force. So this time of impact occurs at a milli of a second in this case, because once you hit it, it's gone, it took off. It's gone when you hit it. So this time of impact happens in the milli of a second. It's very fast. Okay. Now, from this formula, we know that Ft is impulse. This one is impulse, right? So impulse is nothing but the force times time. So impulse is the force acting for a period of time, and this causes the change in momentum. Therefore, the impulse can also be said as change in momentum. Okay, so I, you can say it as Ft, or you can say I equals to mv minus mu. Impulse is a change in momentum. Remember this one. Impulse is a change in momentum. Now, done with impulse. So from this formula, let me erase this again. Okay, if you want to take a screenshot, you just take a screenshot. I'm going to erase this. Okay. F yeah, wait, I'm fixing my pen a while. Give me a second. Okay, suddenly my pen is not working. Okay, never mind. I'll just use the mouse. But forgive me my drawing, because I cannot draw using the mouse. I think my pen will be okay in just a minute. So let's use the mouse first. So F T equals to mv minus mu. Now if I bring this T over there, F equals to mv minus mu divided by T. Now remember, T is the time of impact. Okay, now this one I get a whole new formula. So this one, this F here represents what we call as the impulsive force. Okay, impulsive force. Ft is impulse, only F is impulsive force. So think of impulsive force as an impact force. Okay, so for any impact, there is impulsive force. It can be any impact, like you jumping down the street for whatever reason. So you jumping down the street, there's an impact between your feet and the ground. Okay, or you playing badminton or anything. There's impact. Impact happens in our daily lives, right? Impact happens. So whenever there is an impact, there is impulsive force. Okay. Now, if you look at this formula, F is equals to F is directly proportional to 1 over T. Okay, let's say we take the change of momentum here is constant, fixed. Okay, so you left is what you left is F directly proportional to 1 over T, meaning that if this T value is high, your F value is very small. 你除嘛，你除 T 嘛，如果你除越大的号码，你的 F 越来越小。Right? So 如果你除越小的号码，你的 F 越来越大。Okay? So it's the same thing. It's the same thing. If this T is small, then your F is big. So let's put this into context, meaning that if the time of impact is long, the impulsive force is less. And if the time of impact is short, the impulsive force is huge. Okay, so for example, why is the baseball bat, baseball bat, why is it made of hard materials? What is the reason behind it made of hard materials? Because if you imagine, if it is made of very hard surface, as soon as the baseball comes in contact with the bat, okay, because the surface is very hard, so the baseball will immediately bounce off. It won't rest any longer on the surface. It won't rest on it. It won't stick to it because of the hard surface. Immediately it will bounce off and took off. Okay, bounce away. So this one, we said that it shortens the time of impact. It shortens the time of impact. Okay, so making the time of impact very, very small, and thus the impulsive force very big. So that is what we want, because we want to hit it with high force, right? Okay, So see that how it changes the impulsive force. Later, when you do the calculation, you will see there is a big difference there. A little bit change of time, it will affect F, the force, very, in a very significant way. Okay, so why the baseball bat is not made of soft material? Again, if it's made of soft material, meaning that as soon as the baseball hit the surface of the bat, it tends to rest on the surface. Okay, just like you imagine a cushion. Imagine a cushion. You sitting down on a cushion. A cushion is very soft, right? You sit down and you feel like you are sticking onto it, right? You feel like you're sticking onto it, and you feel like the time of contact between you and the cushion is like longer because the cushion is elastic, right? It's elastic. It's very soft. So meaning that if the baseball bat is made of very soft material like the cushion, so it will prolong the duration of impact. It will increase the time of impact and thus making the impulsive force lower. Okay, if the impulsive force is lower, then you have to 你一定要打很大力，它才飞远 right? So look at how the time of impact changes here. So this is, you see it everywhere in your daily life. You see it everywhere, this impulsive force. For example, you have like when high, oh yeah, okay, I'm going to cut, I'm going to stop here first because it says I have 1 minute left. So let's rejoin, let's log out and log back in because after I write the whiteboard, then I have to redraw again. Okay, we continue. I'll invite you again.